Alright, this is the Go-Kart assembly video. So I'm going to be walking you through how to put this thing together from the sheet metal to the soldering to everything else. I mean, everything short of, putting a battery together, which you should just buy anyway. Um, yeah, so I'm going to show you how to wire everything, assemble everything. There's going to be links to all the hardware. It's going to be, a list of how much hardware you need. This video is going to be very granular. So, if you don't need so much granular detail, feel free to skip around. I go into as deep as how to solder certain joints. So anyway, just wanted to kind of give a layout of what you're going to see here. I do the whole assembly in detail, all stuff like that. But if you have any questions, feel free to reach out to me and I'll happily answer them. But yeah, anyway, let's get on with the rest of the video here. We're going to start with the soldering. All right, Peter here. I'm going to show you how to wire up the controller for your go-kart. This video is very kind of ad hoc. I don't have a script or anything, but I hope this angle is good enough. And I hope kind of show you step by step what to do here. If anything is unclear, feel free to reach out or comment some way. The first thing you want to do with these controllers, so this is I'll link to this controller somewhere. This is pretty much the cheapest motor control you can get for a car like this. You can get nicer ones that, the flipski line is kind of weird, but these are both flipski controllers. This I guess would be considered a nicer one, but I kind of prefer these for a couple reasons. But you can get these too, they're a little more expensive, but not going to be using that today. Going to be using this little guy. This one has a power switch. The cart is configured to kind of accept that, which is cool. This is the motor. This is from a Xiaomi, I forget how you pronounce it in Mandarin, M365. I got this one from monsterscooterparts.com. You can get it from eBay or all kinds of places, but I think this is the 500 watt version. You can get a couple wattages, but I like this one the best. It has a honeycomb tire, looks kind of cool. So what we're going to do here is we're going to wire up the male and female, or the positive and negative here, which goes to the battery. And then we're going to wire up the 3 phase leads and the Hall sensor and a couple other things like the throttle pedal here. So what you got to start by doing is cutting away the plastic around these connectors. This is how they ship it. It's covered in this plastic. Obviously to get to those connectors you have to cut it away. I just use an X-Acto with a new blade in it. It's actually pretty thick plastic. Be very careful not to cut any wires here. You can always solder them back together, but just better if you don't cut them, obviously. Let's cut that away. This is the communications, one of the communications ports. That'll interface with the throttle pedal. There is this, which you can attach to a servo tester. I have one of those around. So you can use one of these guys, it might look familiar, to wire it up or to control the throttle, but they don't make pedals in this style for some reason. I actually designed one. The CAD for it is online. I should really make a sheet metal version, but this is kind of besides the point. This is the pedal we're going to be using. That's uses something called ADC, which is like an e-bike throttle kind of deal. So this part is the power button, and they plug it in like that. And to wire it, logically you need to remove it. So I don't know why they do it like that, but they do. So we need to get this off of here. Unplug this. Okay, and I guess we'll just cut this through to get that off. Once again, careful not to cut up any wires there. Okay, so we got the power button off. And again, we can just, tape this up, put a piece of heat shrink back on it afterwards or anything if you want to reseal it. I usually don't. Just don't use it in the rain. I don't know. You wouldn't use a convertible in the rain. Shouldn't use a go-kart in the rain. I don't know if you live in Seattle or something. I have no idea. Get these two out. So this one right here is the can connector, which I should probably use more. I personally never used it, so I do not cut it out. At least not for a go-kart. I just don't have needs for CAN communication on these things. All right. So that's everything we need to cut out. Here on out, it's going to be some soldering. Quick note about connectors. There's kind of two types of ways to solder two controllers like this. Some of them come with connectors on them. Most of them do not. You can use. I'll do a quick sort of refresher here on connectors because I feel like a lot of people are not familiar with this. Yeah, and for reference, this is going to be very ground level. So if you know all this stuff, you can feel free to skip ahead. You know, get you a couple connectors here as an example. So these are called XT series connectors. They're made by this company called AMAS, I think it's how it's pronounced. So they make ones that are bipolar like that. I don't know if I have one of the smaller triple ones. Oh, right here. False alarm, never mind. They make a kind of tri-lobular one that you can use for motor phase leads. These are really hard to solder. This is actually just a shield for one, but I don't think I have any of these left. But the much easier one, or at least I hope it's easier, to solder would be this type. I think it's MR. You have to double check me on that. Yeah, MR60. So the MR lettering describes the style, and the 60 describes the continuous amperage they can carry. So this is an XT90. This is an XT60. The smaller ones are 60, and they make them down to 30, and you can actually get them on PCBs and stuff. Yeah, right here I can show you this. So this is a female XT60 style connector soldered straight to a board. This is a little battery pack I put together. So we're going to be, if you can, you should always buy a pigtail like this. So a pigtail is just a connector that already has wire soldered to it. Soldering to these connectors is kind of like a little mini skill, and soldering two wires together is just easier. So, that being said, I will start with the more difficult of the two. I gotta grab something to hold on to this while I do it, so I'll be right back. Alright, so I got these vice grips. You'll see why you need those in a second, and why you're probably going to want something like them. Just to clarify, this is how this is all cut. This is open, this port's open, and these two are open. Alright, so I might make a few mistakes here, we'll see. So you want to check which kind of XD connector, if any connector at all, your battery has. So I know that the battery that I'm going to use has a female connector on it. It's actually one of the batteries I showed you before. So I'm going to put a male on this. If you get that wrong, it's not a big deal. You can buy or make an adapter pretty easily. So you want to, generally I like to make sure that these leads kind of like fit inside or close to inside style connector. I guess that's more so on the female. It's nice when they do because it's easier to hold them. I guess I should say that if you don't do a lot of soldering, that's fine. Soldering connectors like this is a little complicated, but as I said before, it's just kind of a little skill in itself. I like to hold on to them with vice grips like this. It's heavy. And whenever you're soldering connectors like this, something that's key to soldering that is kind of makes it more complicated, is that in order for solder to flow over what you want to solder, the two things you want to solder, they both have to be hot. And in the case of an XT connector or a connector in plastic like this, sometimes I can melt the connector, and then when you try and put them back together, they won't fit back together. So I don't know who I saw do this, but whenever you solder a connector like this, just put them together, and then that'll make sure they stay aligned properly. So again, I'm going to do the male side. The square side on XT connectors is always positive, and the kind of cut side is negative. So just make sure you get that right. The other thing about doing this kind of thing is, here it is, heat shrink or some kind of insulator between these two pieces. So when you can see when I solder this, these still might be kind of close together, especially if you cut away some of this insulation, which I probably will, just to make it easier. You're going to want to make sure you put one of these on because this snaps onto this connector. Just sort of acts as an insulator. So okay, let's start soldering. I'll turn on the iron. It's nice to get a good soldering iron. Mine's pretty nice. It has like an auto shut off feature and a few things. If you're going to do a lot of soldering, you know, spend money where you spend time. Get nicer soldering gear instead of just like the $3 iron from Michaels or wherever. Probably more than that at Michaels. So just cutting this away a little bit, just give myself a little more extra space. That looks fine. And again, this will go over that, so should be fine. I'm gonna put a little bit of heat shrink on those just in case they don't fully get up in there. You just want to make sure there's no possibility of those two touching each other. Not a huge danger per se. Actually, it can be. I probably should have said that. It may or may not be a big danger, but it's the kind of thing that you don't want to risk. Like, it doesn't take much time to do it right. And on a controller like this, ideally, you only have to do it once. So, put those on there. Far back away from the solder so they don't shrink. And let's do some soldering. Grab some. I'm just going to put gloves on for this because I always forget to wash my hands after using lead solder. You should have some better ventilation than I do here. If you're soldering, I just have a window open, but you should have a fan or something. Let's see, solder. I like to buy solder in tubes like this. I find that no matter what solder I buy, I generally have a very identical soldering experience. So people might say buy a certain solder for a specific reason, but it's mostly about heat. It's not really about less about the kind of solder you're using, whether it's tin, lead, rosin core, or whatever. Just my experience. Get a couple pieces there. Iron is ready. Got the connector here, so let's get this connector grabbed by the vice grips tightly so it doesn't go anywhere. Again, I apologize if this video is a little messy or slow or something. I did that the wrong way. Not really scripting this. I just wanted to make sure I'm not missing anything, so I'm like barely going to cut this video because I want to make sure that, if you've never soldered before or something, never built an electric go-kart, that you know kind of what you're doing here. So these are slightly different lengths. That's just I'm not even going to cut them. I'm just going to send it the way it is. It's kind of annoying when that happens, but nothing is perfect. This is a tungsten cube. Just to keep everything in the right place. It's nice to have something heavy around. Something small and dense and heavy like that. Alright. This is not an ideal. Probably put this the other way. Remember to put these on too. Almost forgot to do that. I would have been bad. Not the end of the world. Nothing is the end of the world with this, alright? You can always do it again. Put that in. Put the tungsten down on it, so it's not obstructing me. Get a nice piece of solder like this. Make sure it's, nice and straight. It's sometimes easier with thicker solder. It doesn't want to deform as much. Sometimes it's easier with thinner solder. You just kind of got to get a handle on it. Trying to melt my tire here. And then we're just gonna grab this piece of solder. Soldering is kind of like detailing cars. A lot of people think they know a lot about it, and there's like no right way you can do it once you show how you do it. So I'm just gonna put that iron, the base of the iron, or lower down in the iron. Sorry if you can't see this very well. Actually looks pretty good. I just look back at the monitor. Heat the end of the connector like that. Get a little heat into the actual connector. I actually forgot to plug that in like I showed you should do. Oh well. Start kind of... There we go. It's pretty hot already. Just make sure the material is liquid. Try and avoid breathing it in. Okay. And you're going to want to do both sides. So let me... that's pretty much on there now, but I'll plug this in. You're just going to want to do both sides just to make sure, it's just the worst feeling when a soldering connection, you're riding this thing, your kid's riding this thing or whatever, and it stops, you don't know why, and it's because like you made a messy solder connection, like that just sucks. So just like, it's like putting up a building or something, you only have to do it once. So you may as well try and get it right. Again, this connection could come loose again because I'm heating up the joint, which is not uncommon. So you always want to make sure it's secure. That looks pretty good. It's inside a nice hot piece like that. Nice hot connector. Nice hot wire. Solder just... Yeah, it's a good connection. Solder just flowed right in. No problem. Do the same thing for the ground. And I feel like I shouldn't have to say this, but never do this with the battery plug. You're just going to have a bad time doing that. For the record, nothing over or under 50 or 60 volts will be able to pass through your body and hurt you. But, and these batteries I use never exceed that. But they can short on metal things, so you just kind of want to, act wisely, use your brain. Just get a little heat into that. Wire moved naturally. Okay, back. Pretty good. Again, avoid breathing that in. I'll flip the whole thing over. Get that piece of solder again. These gloves do not make it easier, but again, I just always forget to wash my hands after. Make sure you don't melt the wire on the soldering iron. Nice little puddle. And that's pretty much that. Let's turn off the iron. Just give this a minute to cool. You don't want to rush the heat shrink over that. Sometimes it'll shrivel right as it hits the heat of the still hot joint, and then you won't be able to get it over. So I'll just give that a minute to cool, and then I'll be right back. Probably going to be a pretty long video if I take this long to solder two connections, but you know, I figure it's better to have too much detail than not enough. Not enough people explain this stuff to you when you're just starting to do it, so I figured I would, you know, really go the extra mile here. Let me see if I have my, I do. So, different people have different ways to kind of cure heat shrink or shrink heat shrink. I like to use a creme brulee torch. These kinds are nice. Just a good thing to have, generally. It's a little bit of heat on there. Look at that. We'll keep that around. This guy can stay as long as he wants. We just put that over. Takes a little bit of effort there, so don't be afraid. Don't be afraid in general. And look at that. Look how pro that looks. Look how great that is. If that's your first solder joint, you're like you know, a million miles ahead of thousands of other people on the internet. Kind of patting myself on the back there, maybe. But anyway, now we're going to do these. This is the phase leads. So let me explain something about phase leads that no one ever explained to me. I'll do it with the motor. That'll be so much better. So let me explain something to you about how electric motors work, just very briefly. I'm not going to get into any theory here or anything uninteresting. There's nothing uninteresting to me about electric motors, so it's kind of hard to say about it. Motors like this will have 3 wires coming out, and then instead of smaller wires, 5 or 6. Typically with a connector like this. You might be thinking, Peter, 3 wires. You know, what the fuck is that? And that's a great question. You know, outlets typically 2 or 3 ground neutral, but an outlet, the third prong is. Let's not get down a rabbit hole here. Motors have 3 phases. Some of them have 6 phases, but those are just basically 2 3-phase motors. It's hard for me not to get down rabbit holes. That is script. I'm sorry. 3 connections. You're basically just connected to 3 sets of electromagnets, and since there's 3 of them, there's no wrong way to wire this. Is what I'm getting at. Basically, if you can imagine like a piece symbol, like a pie chart with 3 pieces, and then label them 1, 2, and 3. You can't actually get them out of order. Like you can't make it go 1, 3, 2, or whatever. So it's the same thing here, and it's actually the same thing for the hall wires. So the hall wires have 5 connections, sometimes 6, or sometimes an extra temp lead. Well, the kinds of motors I use never seem to have that. The VESC does, unfortunately, so that kind of makes it a little more complicated. But there's a power, a ground, typically 5 or 3.3 volts, and 3 hall sensors, which are doing actual magnetic detection of where the rotor is located, which means you can start from a dead stop. Because otherwise, wouldn't know where it was. You can kind of push start it sometimes, but often not. So, and since there's 3, just like the motor phase leads, you can't wire it wrong, basically. Or else, at least, I've never tried to wire them in a specific way besides kind of crudely matching colors. And I've never gotten a wrong wired hall sensor, so those were 2 things that no one ever told me about this when I started, so I wanted to tell you guys. So now, we're going to have to do a little wire stripping, a little wire cutting. I think I got to grab another tool here, so give me a second. Alright, I'm back. Gloves back on. Probably don't need these. Well, we're going to be soldering still, so might as well have them. So I don't know why these come with these kind of spade connectors. That's like shit. So just gonna cut these. Never be afraid to cut. Never be afraid. I'm not just gonna get out of specifics there. Cut all those off. Neighbor's pool somewhere. Throw them out. It's okay if they're not quite the same length. You can all cut them to the same length if you want. Here, let's do that. Be not afraid. There you go. You have to strip these wires now. A couple ways to do this. I like these things. Some people don't. I remember my roommate in college had one of these. I was just like amazed the first time he used it. And as soon as I started doing more electronics work, I bought a pair, and they're pretty cool. Not so good for small wires, but for bigger stuff like this, it's very good. Be a little generous there. Give yourself, you know, half an inch, and just strip it. It might have actually been a little too tight. It's alright. There you go. Alright. Got those stripped. And this unfortunately will not... Hold on, I should have showed you this earlier. Every controller will come with this little chart, which you can find online, but it's good to just have it around. This shows you in this kind of plan form where everything goes. So the hall connector is ground, hall 1, 2, 3 power, but in this case it's ground, hall 1, 2, 3 temp, and then power because it's 6 pins. So you have to buy a new, it's called the JST connector, and you have to resolder it. So actually I think it might come with one. It does, it's right here. You might use this connector for something else. You should just buy a bunch of these JSTs. It's kind of the... Make sure you find the right pitch. I think these are... Oh, I forgot I have to measure them for you. I should measure them for you. Let me measure them for you. We're back with the calipers. Let's see. Millimeters, please. 1.81, maybe 2. Probably 2. Yeah, I'd say it's a 2 millimeter pitch. Come in a bunch of pitches. They come pretty big actually, up to like 0.1 inch pitch. But in any case, all this is, I think, 2 millimeter pitch. So just get a bunch of 2 millimeter JST connectors or pigtails. If you're going to do a lot of this stuff, I just recommend it generally. They're good little connectors. So, in any case, we were going to wire this up, right? Wow, we got on a little bit of a tangent there, huh? Story of my life. Alright. So, now that we know there's no way to wire this wrong, we just have to pick, do we want male or female on the motor versus the controller? Let's go both male on this. That just feels right. So again, where's my heat? There it is. Make sure you buy a bunch of heat shrink. Now I have all this shit all over the place, but it's the kind of stuff no one tells you to buy. Black or yellow? Let's go black. Heat shrink is one of those things where you don't want to go too big or too small when you're putting it on. A good rule of thumb that I like is, you know, you want it to be over it, and if there's a little kink in the wire, that's enough to kind of retain the heat shrink. You don't want it to be too tight, because a little bit of heat can get on it, and it'll get tightened in a place you don't want. You don't want to be too big. Too big's not really the end of the world. None of this is the end of the world. But too big, it just won't come down and tight on. You just wasted some heat shrink. And reminds me of my home economics teacher in high school, middle school, who said you should only use a dime size of dish soap to clean a whole batch of dishes. And later in life I thought, why would you do that? It's not like dish soap is expensive. But I'm kind of, I guess as you get older, I kind of got more like her. Anyway, I thought that story was going to be funnier. Let's find some stuff to just kind of get these two, you know, when two cables love each other very much kind of thing. Here's so we can solder them together. There it is. That, make sure it's secure, and then so we'll use this. How great is that? Things have some clamping power behind them. Some grip, if you will. Alright. So these wires are typically, they call it silvered. There's already solder on them. That doesn't mean you don't have to add solder. It just means it's a little easier. Let's see. It's pretty still. Okay. Just making sure that the wires are not out of order, or not the end of the world again if they're like kind of braided, but just nice if they're not. My iron is still heating up here. I think we're getting, there we go. This may not seem easier than soldering connectors, but trust me, it is. You can also use a torch to do this, and you'll seem cooler to your friends. Sometimes I do that with small wires just to seem like a cool guy. Let's see. I like that. Let's try the next one. We are just doing great today. A little tug. Not going anywhere. Can't move it with my hand. Alright. Just cover those. There he is. Our best friend. These are just great to have around. Look at that. When you use heat shrink, you just look like a pro. Look at that. Careful, this is usually still hot since I'm wearing gloves. Look how great that looks, folks. Alright. Now there's just more work to do. Alright, we can set this aside for the time being. Need it later, but not right now. Now we're going to do the second, because that was a male on there, so we're going to need a female. I think this desk is messy now. You should have seen it before I cleaned it. Male. There we go. Just make sure. Oh yeah. That's the other reason why it's nice to use a pigtail. So the length of the wire keeps the heat away from the connector, so you don't have to plug them in while you're soldering. Very nice. Alright. These wires are different gauges, considerably different gauges, so it might be a little tricky to get this done, but that's okay. So we're just going to do the same thing we did before. Just thinking about which gripper is best for which wire. And again, I'm sorry if this is in too much detail for someone who's done this before. You can just, I don't know how to do that labeling thing on YouTube, but I'll try and, you can just skip ahead to the programming if you're a seasoned pro at this. I'm going to bend this over a little bit. That looks good. And I will not forget to put the heat shrink on. Almost had me there. This is all just practice. It's like doing anything, you know. The more you do this, the less you forget to put on the heat shrink. Which is just, you know. Make sure you get these little bits of wires kind of organized. It just makes a huge mess everywhere you do this kind of thing. One just fell off my desk. Alright, cool. Slip those on. Maybe I'll speed up parts of this video, make it more consumable. See, that joint played ball. Sometimes they don't play ball. That just is what it is. I will heat shrink these and party on. And that joint fell apart. Alright, let me just get that soldered and I'll be right back. Alright, I actually got that done pretty quick after I got off the video there, but that's just the nature of soldering. Sometimes you look like a pro, sometimes it just sucks. You can burn heat shrink, so don't get too excited about it. All right. Look at that. We got the motor wired and the controller wired with the pigtails. We even used male and female connectors. Alright, now comes the really annoying part. So let's get back to the controller here. Actually, a couple annoying parts of this process. I wish this was all more standardized for you guys. So now we're going to wire the hulls. So this comes with the right connector on one end. Let's make sure. Consult the graph, consult the diagram, 5 volts, red, ground. Okay. That's the hull. And now we're just gonna, can't really go too long here. We're just gonna cut all these. You can make a adapter of some kind if you would like to not cut this cable, but just cut it. Now we have that. What I typically like to do is take the temp line, which is this white one,
and just yank it out because we don't need it. Save that wire or don't. I don't care. Neighbor spool again. Okay. So now we have what we need. We have 5 volt H123 and negative. So now we'll go through the process of, it's too small. These wires are too small to be stripped by that. So generally just take a little bit like this. This is kind of an art as well. Again, you just have to do it a lot. You'll get better at it. Alright, those are all twisted up. Now we'll cut up their friends over here. So we got same thing minus the temp line. Cut this as long as you can. Those are just garbage, unfortunately. And you could make some kind of adapter if you really wanted to, but generally not worth it. So let's get some heat shrink on all those. This is pretty tedious now that I record it. I've done this probably dozens of times. But yeah, it is pretty tedious, I'm not gonna lie. Let's get this size. 4, 5, extra one just in case. The last soldering we'll have to do after this is just the throttle pedal, which is pretty straightforward. Alright, let's get heat shrink all the. You can actually color code your heat shrink if you're so inclined. Pretty autistic, but I kind of get the appeal. Alright, I'd like to do this. First of all, red to red, black to black. Try to avoid tangling them up, it's kind of hard, but black. I just like to take these and twist them together. Crimp them over. You know, bad practice, but if you're in a hurry, I've gotten away with it where I just didn't solder these, and everything was okay. Heat them up, the torch. And it's not cooperating. I was going to look so cool doing this. Oh, it didn't help that I covered it in a bunch of soot trying to use the torch method, but a little bit of solder on there. I'm going to call that good enough. Those things are just not happy. That's okay, they got a little bit of solder on them. Keep the iron on. And just press them off to the side like that, get them kind of aligned, you know what I mean? I like to make sure all my heat shrink is over all my wires before I start soldering, because sometimes you don't know where you're applying heat and you shrink a wire before you apply it. Which is no fun. No good, very bad day. Roughly in the middle. Roughly in the middle. Even if these joints do come apart, it's not the end of the world. You just, you know, cut off the wire. All right, hit the vest there a little bit, but that should be fine. If it's not fine, I'll tell you. Another thing to be careful about. All right, we're making a lot of progress here. Sometimes I put a zip tie on these too, just to keep them together. Anyway, all right, little break, and then we will wire the throttle, which is a little tricky, but should be a-okay. All right, we're back, and this is the most annoying part of this. Well, didn't I say it was less annoying? Annoying in a different way. So the method which this type of throttle uses to communicate with the vest is called ADC. And ADC is used for e-bike throttles, which are obviously not suitable for go-karts, but this pedal uses the same method, the pedals are, etc. So it took me a while to figure this out. It does not plug into this. This is not the same thing, even though it both has 3 wires. Basically, you need a connector that they don't give you, of course. Another JST, I think it's, let's see, this is 6 pins. You want an 8-pin JST if you're really playing it by the book here, which I am not. So I have a 6-pin, which plugs into an 8-pin, because we only need 3 of these leads, as I've showed you. So we only need, I'll put this up on the screen, we only need ADC1, ground, and 3.3. So we don't need, let's see, what would be easier here. None of this is going to make sense. So we're going to pull, don't need 5-volt, pull it out. Just get rid of it. Blow it up. Suck its life out. 3.3 ground to ADC1. We'll need these 3, so we can pull out these 2. It's just that simple, folks. Save these for another project. Or not. Once again, we'll strip these off a little longer than they are. Okay. Always better for it to take a few tries pulling it off than it is to just cut through the wire completely, so don't go too crazy here. Okay, nice. Alright. So in this instance, plug this in, we'll have a 3.3 ground and ADC1. So green is going to be our hot lead, which is that's just the way it's going to be. So you can pull these out somehow. Like that. I don't know. I've done it before. But I'm just going to cut them. You create a lot of little garbage doing this. Connectors, heat, just a bunch of, it's really an unfortunate part of this, but I'm sure someone in the comments will point out some far more turnkey way to do this. But until then, so I had this on a chart behind me. Red is 3v3, as is custom. Strip that. I believe yellow is ground. Sometimes it's green for ground. G, green, ground. Not this time. Not for this Chinese throttle pedal. Alright. You can always cut this kind of larger case around these 3 wires back too. If you cut these too long or short, you mess it up. Never a problem. Just a set. Everything's a setback. Not a impossible, precipice or whatever you want to call it. Alright, we'll separate these out. Heat shrink for all my men. Two more the same size from before. Okay. Not that looking like a moron would be anything new for me, but just down there. This time, we will not use the cool torch method. Didn't work the first time. Sometimes that works really well. I don't know what happens. So green to red. Right? Yep. Right. Always keep the chart handy. Sorry, I went to sleep again. This video is going to be long. Damn. Alright, 3v3. Always double check. Measure once. Measure like George Bush Jr. All right. Okay. Next one is ground, which is yellow. Just double check in there. Just gotta double check. These are close together, so they'll be a little tough to solder, but that's okay. Everything is tough to solder. There's nothing that's really easy to solder. I say if you had like 4 hands, soldering would be like the easiest thing in the world. But you need like a Neuralink chip and some robot arms, and then you could just be absolutely cooking with a soldering iron. I think that's it. Press those together. Watch, I wired this wrong enough to come back later. Oh, again, just a roadblock. Okay. Make sure those all are stuck down there, like the. Before I shrink down the rest of it. Just burn the heat shrink a little bit there, it's okay. Alright. So we got the throttle, we got the hulls, we got the phase leads. This is already soldered, which is great. I think we're ready to hook this stuff up and do a little programming. So your VESC will come with a little USB cable of some kind. Any USB cable that matches the VESC, sometimes a mini USB, micro, I don't know. Whichever one matches is a data cable. It's not just a power cable, obviously, so make sure if you're trying to program one of these, you use a data cable, not just a power cable. Also make sure you use one that's not too long. Sometimes that can affect the voltage and the computer might not pick it up. So to do this, you're going to want to download VESC tool. Go to vesc-project.com. You make an account. You have to add it to your cart and then download it. It's a little bit complicated, but it's not that hard to figure out. If you've gotten this far, I'm sure you'll be fine. We're in VESC tool. Got everything hooked up. So you got your controller plugged into your computer. You got the Hall sensors plugged into your motor controller. You got your motor controller hooked up to your motor controller hooked up to your battery. Sounds like a lot of stuff. It's really not. Power connector or power switch hooked up. If you got all that, time to let her rip. Click the power switch on, and we should be showing up here. There we go. Connect to that. Alright, we're in. So to start, we're going to go to Setup Motors FOC. Do not load the default parameters. We're going to go to Generic. Next. Large outrunner is typically fine. Select your battery cells in series. So if it's 24 volts, it's probably 8. Or actually, I don't know. If it's 10, it's 36. 44 is 12. 13 is 48. So I have 12S battery, 12 batteries. That's not actually a huge deal. Go to Advanced, click Battery Regen. It's 5. Most cells can take that. Current max, I'd say it's 20 to start. Okay. Battery capacity. It's not very important. Not vital that you put this in. I think mine are 3 amp hours each. Or 2.5? Can't remember. Let's say 2.5. Next, you go to direct drive. It's just for your speedometer as far as I know. No polls, don't have to change that. Let me click run detection. And the motor's going to make some noises. And it's going to spin up, which is super exciting. It means that everything is working fine. Going to make a bunch of rotations at a reasonable speed. It's going to go a little bit forward, a little bit back. That's totally normal. Make sure the wheel is suspended above the air. Make sure it's not on the ground for this. Give it a second to think. All right. So we can look at all this great information. We can take 50 amps, just all kinds of great stuff. Sensors, Hall, wow. We're living right now. All right, you can make it go forward and reverse at this point if you want, but that's kind of fun. You should figure out which way your motor is going. So if it goes forward, you should look at it and say, okay, it's actually forward. If it's not a big deal. You just click the inverted thing. So if it was in the wrong way, you just do that, and now it's going in the opposite direction. You just have to trust me on this one. All right, so we're not done yet, unfortunately. So to properly make this motor start from a dead stop, we need to give it some more information. Go to General, and yes, this is right. Click this, okay. Click this. The motor will spin when you do this, so just be careful. And you click Apply. And I forget how this... I'm doing this right? Yes. Click Apply. Got all that data. We are just living. You can, if you want to test it, you can click here. And sure enough, motor is arrow key is spinning up fine from a dead stop. Let's program that throttle real quick. Let me grab that. So we're just going to grab the throttle pedal, get our motor controller. Remember to make sure that's plugged in properly. Everything is going to where it should go. Alright, I got that plugged in. And now we're going to go back to Welcome in Wizards, Setup Input. Next. Going to want to click ADC input like we talked about before. You will see if you see this data changing here, that's a good sign. So we're getting good data from our throttle pedal. That's just awesome. I love seeing that. I'll just reset this. You want to press it down, let it go back to normal, press it down, let it go back to normal. Apply that. Then we're getting from 0 to about 99%, 100%, which is great. Use centered control. Yes, we're going to want to use centered control. If you want to use regen braking, you're going to want to use centered control. This will be, neutral. This will be full power. This will be full regen. And you generally want to use regen. This car, as designed, has no mechanical brakes. It's good that it's aluminum. You can put your feet down to stop it. Regen braking is absolutely plenty. Okay, so for this, a bunch of, I think duty cycle, or current brake center, no reverse, is what I typically go to. A couple of these work. But we're just going to go current no reverse brake center. Right to VESC, app configuration right, okay, finish. And we are cooking with gas. So, and that is it. That's it. If you've never done this before, it may seem complicated. Once you do it a couple times, it is just a lot of fun. Alright, so I'm going to start the cart assembly here. The first step is really attaching everything you need to this. The motor, you can attach the controller later. It's just important to get the motor on here and to get the wires routed through one of these holes here. It's really hard to do once you already have the bottom on. The other thing that mounts on this piece is the power switch. So you gotta do that. You just get the wire through the hole. Obviously this is intentional. Then it comes with a little nut, and you can just attach the power button onto the cart there. You can put everything inside the kind of tube as it's formed in the cart if you want to. It's a lot harder to tune the controller afterwards if you do that. So you can put everything inside if you want, the battery, all that stuff. It's just fun to play around with the currents and stuff, so I recommend you keep it on the outside. Alright, and that's the stuff that connects here. So this hole here is intentionally left without a pin nut. It's designed so that you can put a zip tie through it and attach the motor wire there. So just if you're curious why that's left blank, that's why. And so a pin nut is one of these little nuts. So once you have all that stuff on there, there's really no particular order that this stuff goes on. So I'll just start. This is the main body of the cart. Seat goes here. Front spar attaches here. So we'll just take the main spar. Turn this way. Take this piece. Make sure everything is, all the wires are accessible on the top. Is that going to work? Should leave this on the outside for now. This is actually much easier if you don't attach the motor first, but this is just kind of a good way to do it. Okay. Just want to press these two halves together. Sometimes it's a little tight. And this is the kind of thing where, I'll get this into a better picture here. This is the kind of thing where you're not going to want to tighten up all these right away. You're going to want to put in, one on one side, one on the other. And just take it easy. But don't tighten these down all the way. Just put a couple in. These are the 1/2 inch quarter 20s. Gotta make sure everything's roughly aligned. Okay. And flip it over. Actually aligned very nicely. All right. Next couple here. Now we can just safely tighten all these down. So if you have a clutch on your drill, set it to a spot you feel comfortable. All right. So again, you can run these wires in. Get this closer to the camera here. You can run these wires in through here, which is just a manufacturing feature. And they're not impossible to get through. But as I was saying before, just easier if you can get them in before. So, not the end of the world, but I'll do that later. Alright. So now we're going to want to do the front spar, which is actually probably one of the harder parts about this. Maybe I should do that first. I don't know. There's no real right or wrong way to do this, honestly, which is nice. Pat myself on the back there. We'll get this here. This is where having the something to rest up against this comes in handy. So again, just a matter of getting the stuff lined up loose before you do anything rash. And you're going to want to make sure this is the right side up. You're going to have 2 bolts on the top right here. There's going to be 3 along the bottom. So just make sure. I've done that so many times. Maybe I should make that impossible somehow, but I don't really care. I'll get my Allen keys in here in a second and I'll tighten that down properly, or maybe I'll just try and do it now. You know what? I'm going to leave these loose for now because there's another piece here that has to go in. Next piece is this. This holds the steering column. Pretty cool part, if you don't mind saying so myself. That might need a little convincing to go in, a little squeezing, but hopefully not a problem. You're going to want to line up these side, I'll get a better angle for you. You're going to want to line up these side bolt holes first. Right there. Are anymore, but you want to pull this up as far as it'll go, basically, to put these 2 top bolts in. Probably a little more tolerance here. Sometimes these are pretty tight. Okay, so this is where you're going to want to tighten these bolts here. These 4 that we were doing before, and make that T-joint. Now we're going to want to tighten those up. It's easier to do that with these all the way in. Or most of the way in, rather. Not all the way in, most of the way. You can see that fine. Get this mostly in. Okay. Now I'm just gonna put these down by hand. These are at a kind of an angle and they're easy to strip, and I want to be able to feel it. Okay. Especially those. Along the bottom there. You really want an Allen key for that, but these will go in now. These are just kind of like insurance fasteners, honestly. I don't really think they're even necessary anymore, but you know, I like them. This is a spot where having the seat is handy. I remember it being handy. I guess it's not really handy. My mistake. It's where the bottom plate goes on. Like this. This is a couple quarter 20s here. Another tolerance stack area here, but it still works. Flip this back over. We're going to get to some more fun parts here in a second. So we can either put on the steering column or the seat. Let's put on the steering column. Steering column is fun. I'm going to put on some gloves for this. All right, I couldn't find any gloves, so we're not going to put on any gloves. All right. So you'll notice your kit came with some small pieces. Those two. Those hold on the steering column, which is just a threaded rod, which is a pretty good idea if I do say so myself. That was one of the key innovations of this thing. It saves a lot of hardware doing the threaded rod, let me tell you. So you want to take this piece through there on the bottom like that, not on the top, on the bottom. Doing a quarter 20, and again, not tight. Just get it down, kind of just when you start to feel a little resistance on the fastener. You'll see why in a second. Okay. And we'll do the bottom one here. Move back a little bit so you can see it better. It's a good enough shot. Okay. Should have counted these before put this thing together, huh? It's alright. Count it afterwards. Okay. Now we're going to install the steering column, which you should instead. This is just a screwdriver, an electric screwdriver, but you really want to drill for this part like this because it's pretty fun. Alright, we got the steering column here, 1/2 13, 24 inches long. This is straight off McMaster, and it is dirty, like these all come, which is why I wanted to find gloves, but no matter. So you'll just thread that in the first hole there, and then take your drill, chuck it all the way out, chuck the end of the threaded rod into the drill, make sure that's aligned and that you're not cross-threading it on the bottom there. good enough. All right. Now, a little bit of steering work here. Back this up a little bit. I'm going to use these half inch 13. That's fine. These are serrated. If you don't use serrated, it doesn't work very well. Make sure you use serrated ones. Put that on there. It's your pitman arm. Okay. And you can just tighten this down now. Get an adjustable wrench, 2 adjustable wrenches, or vice grips, and just run those nuts against each other. Pretty much as hard as you can. Feels pretty good. Feels a little stiff, but that's okay. I think we're in a good part of the world here. Alright, we can tighten these down now. Where did I put my screwdriver? There it is. Now this is another prime Allen key candidate. But that's okay. Wheel. Do a lot of stuff next, honestly. You want to make sure you don't chuck it into the drill. See if you can see that better. You want to make sure you don't chuck this into the drill too hard, because you can obviously mar the threads. But the steering wheel just goes on like that. Obviously the top nut goes on. Make sure you're getting good thread engagement there. You are going to want to make sure these are aligned, which is easier said than done. Okay. If you do that right, those will not come apart. It just needs a little bit of grease. Anyway, next steps. This can be a little bit annoying, this part, but see how much I struggle through it. The steering components of any vehicle define how the steering feels, particularly the tolerances between them. So you're going to want to have pretty tight tolerances if you want your steering to feel good, and I want my steering to feel good, so sometimes these parts are a little bit tight is what I'm getting around to. But what you're going to want to do, get one of your knuckles, one of your nylon, or they're not nylon, they're Delrin spacers. Or I guess I should put it like this. Like this. Get a bolt, put it through partially. Actually, we're going to want to put a spacer on here too. And you can't go wrong left or right with these. They're the same part, left and right. So this can be a little tight. This one's not giving me much trouble, which is nice. And we're going to want to slip another one of these into there. Let's give it a little press. Make sure everything's aligned. Okay, we're in. Another one of these to the bottom. You can see that. And then make sure you're using, hey, actually it doesn't really matter. Use a lock nut. and you can tighten that down later. Actually, it's not really critical that it's super tight. And then we have one side here. And let's do the other side. And so there's two ways to attach the wheels. So you use these bolts to attach the wheels. It's another 5/8 inch bolt. You can either install the nuts, or install the bolts rather, before you do that process. I always forget every time, so I never do. You just have to put the bolt in afterwards, like this, and then you have to reach in with a nut and tighten it that way. It's a little annoying. Makes you wish they made a 5/8 inch PEM inserts. That would be nice. Anyway, that phase of that is done. Now, a little bit of a chat about this part. It's one of a handful of steel parts that are still present on the cart. It's mostly aluminum, but the knuckles and this part is still steel. That's just because I don't trust aluminum to hold up over long term, just being pushed and compressed and expanded like that. It probably would be fine, but what I'm getting around to is that to prevent galvanic corrosion, these parts are all powder coated. And the powder coating makes these holes in the end a bit tight. So sometimes you have to run a nut into or a bolt into them and out, just to kind of clean it out a little bit, form a thread sort of. And then after that, they'll go in just fine. But you'll notice there's two kind of holes here. One that's right up to the corner, another that's not quite up to the corner. This is the top side. It goes on like this. So the holes, sorry I'm putting the mic there. The holes on the outside are the ones that plug into the knuckles. This is kind of a tricky process. So what you want to do is get your nut right here and then attach it. Probably flip the card over for this. From the bottom. Give that a little bit, twist it in a little bit. Then you're going to want to make sure that it's like an aerodynamic style. There's the inside and the outside. You're going to make sure the outside is pointing forwards. Just make sure those are getting to know each other. You want to get it kind of the bottom end and that nut or that bolt flush with the top of the track rod. I think that's a technical term for it. It's one of the few nuts on the assembly is here. You're generally going to want to use a nylock there. Just don't have any on hand. But in the hardware recommendations, I do say you use a nylock, some kind of lock nut. Because you want it to be, this is a pivot, right? You don't want it to be stiff on there, but you don't want the nut to come loose. So. It's awesome. Even has a little bit of acromin in it, and a little bit of caster, which is cool. Makes the steering feel nice. And self-centered kind of, which is cool. Right, flip it back over. Alright. And now, kind of at the finishing stages here, which is cool. I do have nylocks for these, even though they're not super necessary, but you're going to want to make sure that you do this, that the pivot arm is facing up, not down. If you do that, when you turn right, the cart will turn left. So you want to make sure this part is facing up. Then we're just going to attach one of these little rod end kind of connection rods. Connection rod's the wrong word, but you know what I mean. These are quarter 28. Unfortunately, they don't make these in quarter 20 for some reason, or else I would have bought the quarter 21. So. And then we just gotta install the connecting rod. Look at that. This is also quarter 28, which kind of drives me crazy, but it's alright. Good enough. Alright. Steering we got. Okay. Move this over, we'll put the seat together, then we'll put the wheels on, and we will be all done. And you will have a go-kart. How fun is that? Hasn't this been fun? I've been having fun. The seat is pretty satisfying. A couple more quarter 20 as usual. Nothing crazy there. These just get bolted in. Easy as that. Looks pretty good to me. All right. Now, see how light that is. It's really light before you put the hub motor on. This is a bend tolerance, and sometimes the seat might not fit quite right, but it always has never not fit for me. Sometimes a couple of bolts are a little tight. And the last thing is just the front wheels. These are $8, depending on if you have a coupon or less. 10-inch wheels. 11-inch? 10-inch? I think they're 10-inch wheels from Harbor Freight. Get the zinc hub, you can get a gold zinc hub, get a white hub or a black hub. So whatever color wheels you want, you can get, which is pretty cool. So now we just have a couple more bolts here. You could use the same bolts for the steering axis and for this, but you'd have to make sure you put them in first before you install the knuckles, or else there won't be enough room in there to tighten it down. Let's do a little compromise. If you're going to buy the hardware from somewhere like Tractor Supply, you know, it doesn't really matter because you're going to buy in bulk anyway. If you get them off McMaster, you know, you might want to buy the same fasteners just to save a little bit of money. But anyway, usually put the wheels on like this because, as I said before, I always forget to do it the other way. This is a lot easier to do with a drill and a socket, so I will do that. You know what? Oh, yes, I will do that outside. there's your go-kart. There it is.
Alright, here's the finished cart. So I'm just gonna show you around, give you a couple tips here, and show you the wiring. So the pedal, these little openings here are manufacturing features, but they're good for routing wiring as well. That's why they're positioned where they are. So the pedal wire goes up through here, up to the controller. I like to put them through this hole here, and just zip ties it all together. I have some double-sided tape on this battery, keeping it in position, so that kind of locates the controller as well. Motor phase leads, hall wires, I put those through this hole, and you can see that I got this zip tied here. Again, that's why that hole is left blank, and then into this manufacturing feature to go to the controller. And the power button is under this right here, as we mounted it before. So turn it on. Controller will make a little, there you go, little squeal. And from there, you're ready to rip. Pretty straightforward. Just so I get this on video, so this is not a four-wheel go-kart. This is 3 wheels because it's cheaper and easier to make an electric go-kart this way. As a result, it's not as stable as a 4-wheel go-kart. So don't think you can really carve corners in this thing, because you can't. You can move your weight around to do that a little bit, but this thing still will tip over, so just be careful. What did I not do last night? I didn't tighten the wheels last night, so make sure you don't over-tighten these, because they can just not spin so well if you do that. But yeah, besides that, make sure you're last night I was riding this thing, it felt kind of floppy, and as it turns out, I forgot to tighten up all the bolts. So last night I said, set your drill check setting to whatever you want, but once you get out here, get an Allen key and really tighten everything down, because if you don't, it'll feel funny, and you won't really know why. You might be disappointed, but it's just because you didn't tighten everything down as much as it should be tightened. So yeah, there you go. Hope you guys enjoy it.